So just a quick review of yesterday. In complex numbers, I is root negative 1. I squared is?
Negative 1.
Root negative 1 times root negative 1 or?
Negative 1.
Negative 1. I cubed? Negative root negative 1. And I to the fourth is? 1. Now, we pointed out that anytime you have a fourth power or a multiple of fourth power yesterday, our solution was 1. So if I said, well, if any of these exponents, any of these powers here, if they are a factor of 4, or excuse me, a multiple of 4, then your answer is going to be 1. Well, is 78 a multiple of 4?
No.
Nope. Is 120?
Yes.
Yeah, so that's a 1. 45 and 63 are both odd, so neither one of those could be. Well, 78, though, if it's not a multiple of 4, however it is even, then the answer is negative 1. So when you're looking at these, you go, well, if it's even, it's at least negative 1. If it's even and a multiple of 4, then it's going to be 1. So this one right here, since it's not divisible by 4, but it's still even, this is negative 1. Okay? Now from there, the one before 4 is negative root negative 1. The one after 4, right? If I went I to the fifth, we know that that starts our pattern over. So if we can focus on the 4, if we can focus there, if it's a power right before a multiple of 4, it's negative root negative 1. If it's a power right after a multiple of 4, then it's root negative 1. So is 45, what's the closest number that goes into 45, or that 4 goes into?
44.
44. So, and that's right before, right? So this answer, the one right after, is root negative 1. What's the closest one on 63? It's 60, but there's one closer. 64. That one's 63 is right before, so that means it's negative root negative 1. Okay, so if you can copy this down, if you can memorize this piece, and just remember that I to the fourth really is your roadmap. Okay, if it's a power of 4, right, a multiple of 4, it's 1. If it's before that, it's negative root negative 1. If it's the one right after, it's root negative 1. If it's even, but it's not, then it's negative 1. Everyone get that? Okay, I want you to summarize it to your neighbor and then summarize it in your notes so you're ready for it on your quiz and your test. Try to get it down in words. Questions? All right, you guys, about your quiz, I said 5-4 to 5-6. I'm going to say that there might be 1 or 2 problems from 5-7. That way you're prepared for it. It won't be a big chunk of it, but that way you're prepared for it. I will double check and talk to Mr. Vogel for sure, but just be prepared for that, okay? All right. Any questions? That brings you, there's only 5-8 left after 5-7, then you guys you'll take your chapter test next week over chapter 5. Really, you have 2 chapter tests left this semester. 5 and 6. That's it. Then we have our final. Yeah, crazy. Okay, let's go ahead and you guys going on your notes. Today we're doing completing the square. Okay, 5-7. Okay, we get to complete the square, man. And it's not as easy as like just drawing the picture and trying to complete it. That'd make it a lot easier if it's just. Be so cool. Then you just like fill it in. Then you'd be done. But, yeah, that's not what it is. We're going to complete the square though. So get your learning goals down. Binomial, some definitions that you need to know. A binomial has 2 terms. For example, x plus 5, that's hopefully a review. Trinomial has 3 terms. Has that x squared plus 10x plus 25. Remember, terms are separated by addition or subtraction signs. A perfect square trinomial is the product of a binomial that has been squared. So if you think of like our HK, it's like the piece that has our H in it. right? So x plus 5 quantity squared, when we multiply it out, the product of a binomial that's squared gives us a trinomial. That's a perfect square trinomial because if you were to factor it, it would give you x plus 5 times x plus 5. Okay, the process of finding the last term of a perfect square, so finding this thing back here, that 25, so that we can write it in this form, is called completing the square. And that's what we're doing today. There's benefits to writing it in the form of x plus 5 quantity squared. And we'll talk about that here after you get some of those notes down. All right, so to show you the benefit of having it in this form, let's do a different problem. Let's say I have the equation x plus 4 quantity squared equals 7. Okay, now we've talked about being able to solve those problems, right? Rather than having to factor, rather than having to multiply this out, what do we do to solve this? Yeah. Good. As Tyler said, we take the square root of both sides. So that leaves us with x plus 4 here. And on this side, we have plus minus root 7. Right? And now what do? Subtract 4. So x equals negative 4 plus minus root 7. Now we could put that in decimal form pretty easy using our calculator, or we could leave it in that form if that's an okay form for the assignment you're doing. But pretty easy to solve them, right? So if we can get something into this format, it makes it easier to solve. And that's what you do when you're completing the square. Okay? You would be taking a quadratic and saying, well, I want to make this a perfect square trinomial so that I can put it in this form so that I can solve a problem. Very easy. Okay? That's our process today. Any questions there? All right, well, let's try some of these. Turn your note page over. First thing that we're going to do is we're going to multiply a couple of these out. So x plus 2 quantity squared, remember, x plus 2 quantity squared means that x plus 2 times x plus 2. And then when we're multiplying it out, recall that x times x, that gives me my x squared. And then x times 2 gives me my 2x. And then x times 2 gives me my 2x. And then I multiply this back thing, and notice that's 2 times 2, or 2 to what power? The second. Okay? You can think of it as 2 squared, which is really 4. All right? But I'm trying to show some patterns here. So how many 2x's do we have?
4.
Well, we have 4 x's, but we have 2 x's, right? That ends up giving me x squared. 2 x's is 4x. And this is squared, so that's 4. Okay? Oh, thank you. So I'm hoping that we start seeing some patterns here. This 2x is doubled. There's 2 of them. That gives us the 4x. The back term, the 2, is squared. That gives us the 4. Or if I look at this, my front term, x squared, my back term, 4, those both get squared. X squared and 4. And then if I multiply 2 times x and double it, I get my middle. So using that pattern, when I multiply this out, I should be able to go, well, it's just that squared, which is x squared. And the last term, my c term, is this squared, which is
9.
positive 9. Yep. And then my middle term is that times itself doubled. Right? So 3x doubled is 6x. Yeah?
So in this case, the c term will always be a perfect square.
Always be a perfect square. That's why that's part of completing the square there. So everyone, in your head, multiply that out. X plus 4 quantity squared. Using patterns there.
As far as
Okay, nice job. Yep. First term is x squared. Back term is 16. 4 plus x, or 4 times x doubled is 8x. Heard a lot of you say that. All right. How many got it? All right. Well, let's use that pattern now to complete the square. Complete the square of each perfect square trinomial. Well, we know that if I'm going now from this form to that form, which is what I'm doing down here, which is the process we're going to have to use, we're going to have to go backwards now. Okay, well, if I need to find my back term is always what part of my middle term? That's kind of what I'm looking for. So how did I get my middle term again? From this?
Multiplied by 2 basically.
Tell your neighbor how you got from here to here.
Multiplied by 2, so you would have to divide by 2 on this one.
Okay, so what did we do? Parker?
You doubled it.
Yeah, I doubled it. I multiplied it by 2, right? I took 4 times x and I doubled it. Okay, so if I'm already here, how do I get back to this? Yeah?
Well, like the 18n, you divide that by 2 since you're doubling that.
Okay, so I'd have to divide this by 2 to get back to here. So like in this one, I divide it by 2. If I divide this by 2, it gives me that number. Everyone see that? Half of this is that. Half of this is that. Half of that is that. Okay? So we always divide that term by 2. How do we get the back number? Connor?
Square the back like the last number.
Yeah, so once you find this, you just square it. Okay, and so that is 81. We have now completed the square. We've now made a perfect square trinomial. So your back term is always half of your middle term squared. This part becomes n. How do we know it's plus here, not minus? Yeah, B and C are both positive. In fact, can C ever be negative if this is a perfect square?
No.
No? Good, Tyler? So in this one, what's my symbol going to be in the middle?
Minus.
It's going to be minus, whatever your B symbol is. Okay? What goes here?
Okay.
Okay?
Minus.
Okay, everyone figure out the rest. This blank and that blank. Work with your partner there. Okay, a bunch of you are cruising right ahead. You're working through these. That's great. This one cut in half. That's 12 squared is 144. You guys, this thing right here, this is the perfect square. The trinomial is. The binomial is not, I mean, it's a binomial that's being squared, but your perfect square is up here. It's a perfect square trinomial. That's the square you're completing. Okay? So what about this one? This is going to be x. Going to have plus or minus?
Minus.
Minus. Yeah, it's 1/2. And I would tell you to put it in fraction form because when you square that, that's easier to square. You square the top and you square the bottom. So those of you who can't recall that from when we've dealt with fractions in the past, when you square 1/2, you're squaring 1 squared and 2 squared. So that becomes 1/4, which right now you're like, well, it doesn't really matter on the top, but if that was a 2, then that would be a, you'd have to square and be a 4 up there. Okay. All right, I want you to finish up that page if you haven't done so already. If you have, you can take out a piece of paper for your assignment that we're going to be going through here in a minute. Okay. Hey, this is x plus 10, and back here is 100. Good. Cut in half, and then square it. Okay. This one is m plus or minus? Minus. Yep. And cut in half, we get 3/2. Squared is 9/4. Any questions there? Okay. X plus 2 and 4. All right. How many think you got it? It's all about the patterns there. Okay, let's try some of these off your assignment. Just so you know, we're going to do about 5 problems together. Okay? And the goal now is to solve. Solving quadratic equations by completing the square. There's 2 situations. When a is 1 and when a is not 1. When a is 1, you're happy, happy, joy, joy. When a is not 1, you're still happy, happy, joy, joy because you're doing math. It's just not as much joy, joy. Maybe it's just happy, happy, joy. No, you don't get 2 joys. Okay. All right. So let's start with number 1. First thing I would tell students to do, and you'll see it approached differently in different books, but I always tell students to move the constant over to the other side. So like number 1 and number 2 are set up really well like that. Number 3, notice the 21's right here. It's on this side. I would suggest moving it over. Okay, so I would always just have A and B alone on one side. Because what that does now is it gives me a situation like we were just dealing with, where I'm saying, really, I'm trying to complete a square, so I'm trying to figure out what I'm adding to the back, and whatever I do on this side, I have to do on this side. I've got to add that same amount on there. Everyone get that? So really, we're not changing much of what we're doing. I mean, we're still trying to come up with exactly what we did previously, what we're doing right here. We're trying to figure out the same thing, what we're going to add to the back. It's just now we're putting it in an equation format, so whatever we add here, we have to add here. So if I'm trying to make this into a perfect square, tell your neighbor what binomial that makes.
It would be 16.
Okay, let's ignore the 9 on the backs. Okay, so what goes here? 4. Yeah, you just cut that in half, right? And then what are we adding then? 16. And whatever we do here, we have to do over there. Whatever you do to one side, you have to do to the other. Okay, now this has now given me a binomial squared. Now just so that everyone's clear, and this is where students usually start making mistakes. I hope that you'll pick this up, that this thing right here has transformed to this. They are the same value. This became that. So my new equation now, after one step, is x plus 4 quantity squared equals 9 plus 16, or 25. That is my new equation. I no longer am dealing with any of this stuff up here. This thing compacted is that. If I were to multiply x plus 4 quantity squared out, I would be back at this. That's the point of completing the square, is to get it to this form. Okay? Solve it from there now. Okay, first step is take the root, right?
X plus 4 equals plus or minus 5.
Okay, and then from there, subtract 4. Negative 4 plus minus root 25 is 5. So those are my two answers. You've got to simplify it though. Negative 4, this is negative 4 plus 5, and negative 4 minus 5. Negative 4 plus 5 is 1. And negative 4 minus 5 is negative 9. That is what x equals. Now, some of you are pretty bright. You look at that and you're like, 1 and negative 9. Dude, I could have factored and got that.
Yeah.
I mean, I could have just subtracted 9 over and factored, and I would have got my answer a lot quicker. You're right. This is just another way. I mean, we've used calculators now to solve. We've used factoring. We're using completing the square. We'll use the quadratic formula. And at matrices, at the end, you have all these tools in your bag. They all do the same thing. It's just up to you which one you want to use. Okay? How many think you got it there? Okay, try number 2. If you have questions as I'm walking around, make sure you ask. All right. So I'm looking for x squared minus 2x plus something equals negative 6 plus that same something. So we want to know what we're putting in there. So this is going to be x minus because b is negative. What are we putting in? Yeah, half of 2, which is 1. And then we square it to get this, which is also 1. All right, so this thing, this deal right here, oops, once again becomes that. So we get x minus 1 quantity squared, all equals negative 5. How many made it that far? Good. Okay. And so now, any questions there? Okay, so from now, we got to square both sides. We get x minus 1 equals negative 5, or excuse me, take the square root of both sides. Square root of negative 5. Get our plus minus in there. Now some of you will look at that right now and automatically know that this is going to become, you're going to have an I there, right? Because the negative inside. So now we have x equals 1 plus minus the root of negative 5. And to simplify that, we've got to pull that negative out. Many of you get really good. You say, well, I'm just pulling the negative out, so that just means there's an I out in front. I root 5. And we can't go any further, so those are our answers. Okay, any questions there? Okay. Try number 3 if you haven't done so. Give it a go. Try to keep both of them up there. All right, here we go. First step, move that 21 over. X squared plus 4x equals 21. How many did that first? You're good? Okay, next step is to figure out what we're adding to the back to get that binomial squared. So it's going to be x, it's going to be plus, cut this in half, right? So cut it in half, we get 2, and then square that to get that, we get 4. Okay, so we've got to add 4 to both sides. So recalling, this thing has now become this. Okay, so we have x plus 2 quantity squared equals 25. Take square root, x plus 2 equals plus minus root 25. Subtract 2, x equals negative 2 plus minus 5. So my two solutions there, I get x equals negative 2 plus 5 and, thank you, x equals negative 2 minus 5. That's 3, that's negative 7. How many got it? Good. Could you have factored it? The way you know, some of you are like, yeah, some of you are like, you know you can, some of you, I heard one person say sure. I don't know if that's like a confident sure. Okay. Hey, if you guys, if this number is rational, right, that means it can be expressed as a fraction, then it could have been factored. If it's irrational, it couldn't have been factored. This could have been factored. In fact, I know it would have factored to x minus 3x plus 7. How do I know that so quickly? Well, because yeah, it's what would make that 0, right? That would have factored that right there. So is different or completing the square the quickest way? Probably not. Factoring probably would have been the quickest. Okay, but it's just another method for you. Okay, any questions there before we move to the joy ones, not the joy ones? Okay. Number 28. All right, when A is not 1. A is not 1 here. First step, tell your neighbor what you're going to do first.
You have to divide by A to get.
Oh, man, you guys are jumping ahead to the second step. All right, what's first step? Heard a bunch of you say the second step. First step.
Add 4x.
Yep, get the x and the x squared on the same side. So we have 3x squared plus 4x, excuse me, equals 5. And then I heard a handful of you actually say the second step. When A's not 1, yeah.
Divide by A.
Divide by A. Make A 1. Right? The way you make A 1 is you divide out that A. Divide everything by 3. Now, some of you look at that and go, that's ridiculous, man. Because now I have a fraction right there and a fraction right there. And if I didn't love fractions, then that would be horrible. But since you guys love fractions, not that big of a deal. Right? All right. So we still go through the same process now. The only new step is that we divide by that A. Same process. Finish it up there. So those of you that aren't really good with fractions, I mean, you'll get the x and the plus, and then you'll try to break 4/3 in half. Just remember, 4/3 is what plus itself makes 4/3? 2/3. Right? You just cut in half the top number. 2/3. And then 2/3 squared, well, when I square a fraction, I square the top and the bottom. That gives me 4 9s. So cut that in half, square it. This is 4 9s, which makes this 4 9s, which makes this ugly. Right? Not too bad, though. Like 3 goes into 9. How many 9s is 5/3? Going to multiply that by 3 to make a 9. Multiply this by 3 and make it 15. 4 9s and 15 9s is 19 9s. I now take the root of both sides. I get x plus 2/3 equals plus minus 19 9ths. The square root of that. Now the square root of 19 9ths is the same thing as the square root of 19 over the square root of 9. And I like that form because I can't have a radical in the denominator. It gives me root 19 over 3. Plus minus root 19 over 3. And now I have to subtract 2/3. X equals negative 2/3 plus minus root 19 over 3. Now, since these are the same denominator, the other way you could write that, probably the way you'd see it more often, is negative 2 plus minus root 19 all over 3. Either of those answers would work. I know, pure excitement. It's true. Totally. That's the answer. Like over 3. Even over 3. Yeah. Well, you can't divide this out, right? We'd have to round it because it's irrational. Yeah. All right. Last problem. Get as far as you can. You get 2 minutes on it. Okay, first steps, move that over. Next steps, to divide by 5. How many made it that far? Good. Next step, set it up with our squared. We have x minus because b is negative. Half of 2/5 is 1/5. Oops, 1/5. Thank you. Proofreading. So what are we going to add there on both sides? Well, 1/5 squared is 25th. Okay, so x minus 1/5 quantity squared is equal to, what is 1 in terms of 25ths? 25 over 25. So this is 26 25ths. Take the square root, x minus 1/5, 1/5. Holy moly. Can't write that without writing 1/2. Is equal to plus minus root 26 over root 25, or 5. Add 1/5. X equals 1/5 plus minus. Or
X equals 1 plus root 26 all over 5. Plus or minus.
that was a bad. All right, pretty cool. All right, your assignment. Your assignment, take a look at it for today, and you're only allowed to spend about a half hour on it. Well, I mean, if you really want, you can spend more, but we'll be completing a little more, and you'll have more time in class. You'll get more of an assignment tomorrow. We'll actually cover example 3 tomorrow, but there we go. First column on example side.
That's not too painful.
Not too painful. Some of you, a couple of them you've done. Okay?